Hey guys, it's Mr. Glad here. Today we're going to take a look at the combined gas law and review some of that. It's something we've done earlier, but just giving you another chance to take a look at it. We'll see an example. I've got both the Glad method and the Chaudhua method, depending on how you like to do that, and give you an opportunity to get some practice. And later on, we'll have a chance to take a quiz. All right, let's get rolling. Our example here is a 10-liter sample of nitrogen gas at a temperature of 0.00 degrees Celsius or 273.15 Kelvin, has a pressure of 110.5 kilopascals. What will the resulting pressure be if the temperature is raised to 150.00 degrees Celsius or 423.15 Kelvin and the volume is reduced to 5 liters? So we can go ahead and start pulling out some of the key information there. You probably noticed already that the temperatures will need to be converted, but they are in the problem in both ways. Remember, we always wanted to use Kelvin in our gas law problems. So the first thing is the volume. V1 is going to be 10 liters. Our T1 is going to be 273.15 Kelvin. And our pressure, 110.5 kPa. All right, so remember the combined gas law, we need two different sets of conditions. The second set of conditions is going to be our temperature being 423.15 Kelvin and the volume reduced to 5 liters. So it's asking us to determine the resulting pressure. So our unknown will be P2. You kind of notice right away, before we work anything out, that in this problem, the volume is getting smaller and the temperature is increasing. So you probably know right off the get-go that the pressure is going to be increasing in this problem as we're compressing it and jacking up the temperature. So the solution, we're starting with our equation, P1 times V1 over T1 equals P2 times V2 over T2. The reason we call this the Chaudhua solution is we just plug everything in as it is. So I'm going to take the P1 of 110.5 kPa and plug that right in here for P1. The 10.00 liters, or I'm sorry, 10.0 liters is going to go in for V1, T1 273.15, and then on the other side of the equation, I put X instead of P2. That's what we'll be solving for. But X times 5.00 liters for V2 divided by 423.15 as our T2. All right, so everything is just kind of plugged in there as is. This is a good problem for cross multiplying. And you've used that strategy a whole bunch of times. When we work that out, we come up with an answer of 342 kPa. I remember what I said before, that we would expect the pressure to increase 342 kPa compared to 110.5 kPa is definitely an increase. All right, so that's the Chaudhua solution. If you like the Mr. Glad solution, I mean, everything is pretty much the same setup in terms of what we're given, what the unknown is. It changes, though, for the solution. And I'll put the whole problem up here, but what I like to do is rearrange that equation first. All right, so instead of P1 times V1 over T1 equals P2 times V2 over T2, I rearranged it so I can isolate P2 all by itself. All right, it's a little bit of legwork in the front, in the beginning of the problem, but you'll notice now it's just a matter of plugging everything in, and the arithmetic on it is just a little cleaner. You don't have to do the cross multiplication and division like we did with Ms. Chaudhua's method. Again, nothing wrong with either of these methods. Choose whichever you're more comfortable with. So we have all of the variables identified here. It's a matter of plugging in the different values. Once that's plugged in, I calculate it and I came up with 342 kPa, which is the exact same answer that we got using the Chaudhua method. So just a matter of whichever one you prefer. All right. There are 3 practice problems that follow in this presentation. Feel free to do those. You can do that on scratch paper or something like that. I did include the answers on the slide following each of the practice problems. Okay, so you can check and see how you're doing with that. There will be a quiz available for you later on today. Probably by the time you see this, it'll already be posted. But it'll be a Google form quiz, and feel free to take that when you feel ready. If you have questions or need help with anything, send Ms. Chaudroy or myself email, or you can contact us through Classroom. Either way, we'll get back to you as soon as possible. All right. Hopefully we're having a great time, and good luck with your problems. All right. Take care.